Hi everybody, Mr. Rubo here. We are continuing with 313, trig and polar coordinates, and we're going to talk about complex numbers, okay? So thinking back to Algebra 2, you guys saw complex numbers as a plus bi, right? That's where that I came in with the imaginary numbers. And so yeah, we actually we'll talk about complex numbers here. So usually you would think of 3 plus 2i as a rectangular coordinate. It's like you're going 3, 2. You can see it here. We just have the real axis and the complex or the imaginary axis as our x and our y. Well, guess what? We can do the same thing as we did with non-complex and change it to polar. And we can do that with complex numbers as well. We can change them from rectangular form to polar form. We just end up writing our answer slightly different. So the way we write it is it's r, so the radius, times the cosine of the angle plus I times the sine of the angle. And that should make sense because r cosine theta is x. And then, oops, I forgot the r here. I think I said it, but I don't know if I wrote it. R sine of theta is y. So this is literally saying x plus yi, which is the a, b, right? A and b were x and y. So that's how we write them in polar. So here we go. Here's an example. A complex number is represented by a complex, or point in the complex plane. The complex plane, or the complex number is -2 minus 2i. Think of that as an x and a y. We can express it as -2, -2 in the complex plane. What is one way to express the complex number in polar form? So what we're going to do is we're going to plot that on a complex grid, which is really just a normal rectangular grid, right? So -2, -2 is down here. We then figure out, okay, we need to figure out what this x value is because that's going to be our r. And you should be able to figure it out without doing Pythagorean theorem, but if you weren't sure, you could throw the little Pythagorean theorem here, and you'd end up getting that x is 2 root 2. And again, you could have figured this out because you see that those two sides are the same, so it ends. That's also very helpful because what we're going to end up seeing here is this is a special right triangle. So we know that side's 2 root 2. So there's our r value. That's actually r. So r is 2 root 2. We now need to figure out theta. Well, theta, you could figure out by doing like tangent of theta, but we could also just look at this triangle and say, oh, those are the same, which means this is pi fourths, which then means because we're in quadrant 3, our theta is 5 pi fourths, right? So once we know those two things, now we just write it in this r cosine format. So r 2 root 2 cosine 5 pi fourths plus I times sine, plus I keep forgetting the r value, 2 root 2 sine 5 pi fourths. And finish those parentheses. And there's our answer in complex polar form. And yeah, that's all you got to do, right? So yeah, thanks for watching. Have a good day.